So let's graph some rationals using holes and slant asymptotes. So let's just jump into an example. So let's say you want to graph the following rational function. So, and here my function is going to be f of x is equal to, I don't know, x squared plus 4x minus 5 divided by x squared plus x minus 2. Okay, so how would you do this part? So right off the bat, it kind of looks like, oh, this is just going to be another type of just the regular, right? So because it doesn't look like this is going to have a hole. So let's just do the same steps that we've been doing. So we're going to start off by factoring it. So we have a lot of factoring to do. So on the top, this is going to be a 5 and a 1 with a positive and a negative. And on the bottom one, this is going to be a 2 and a 1 with also a positive and a negative. So now what you can see is that you have this negative here that's going to go away. Okay, x minus 1. So that guy is going to immediately go away, which means that there is a hole at x minus 1. And the way that we find this hole is to set it equal to 0. So at x equals 1, there's going to be a hole, okay, at that particular point. Okay, so now what you have is this new function. You have this function x plus 5 over x plus 2. So if I plug in this x equals 1 in there, what am I going to get? So I'm going to plug in 1 in there. Okay, so you're going to get a 6 over 3, which is going to give me a 2. Okay, so because 6 divided by 3 gives me 2. So at 1, because that was the x value, comma 2, that's my y value, there is a hole. So there's going to be a hole in that particular point. So let's keep that in mind. Okay, so now what we're going to do is we're going to proceed now with this new function. This guy is now my new function. I'm not going to look at the other one because the other one there was a hole, something went away. So now this is the new function that I'm going to work with. So we have f of x is equal to x plus 5 divided by x plus 2. Okay, now with this one, everything is factored. We don't have to do anything else. Let's find the x-intercepts. So the x-intercept, remember, is when y equals 0. You're going to get 0 is equal to x plus 5 over x plus 2. The bottom part is going to go away, so you're left with x plus 5 equals 0. So x equals negative 5. So at negative 5 comma 0, you're going to have an x-intercept. My y-intercept is going to be when x is equal to 0. So you're going to have y is equal to 0 plus 5 over 0 plus 2, which gives me 5 halves. Okay, so that means that at 0 comma 5 halves, I have a y-intercept. Now let's look for the vertical asymptotes. The vertical asymptotes is going to be wherever the denominator is equal to 0, so x plus 2 equals 0. So you get x equals negative 2. Okay. My horizontal asymptotes, notice that these guys have exactly the same leading coefficient. So y equals 1 is going to be my my horizontal asymptote. Okay, and now let's go ahead and graph this. So the first thing that I like to do is graph the hole. The hole is at 1 comma 2. Okay, so at 1 comma 2, you're going to have this hole on the graph. Okay, now let's graph my vertical asymptotes. So my vertical asymptote is going to be at x equals negative 2. So x equals negative 2. And my y is going to be y equals 1. So y equals 1 is right here. Now let's plot our points. Our points are going to be x-intercept is negative 5, 0. So negative 5, 2, negative 3, negative 4, negative 5, 0. And then we're going to have, where is it? Oh, here. 5 over 2, which is going to be 2.5. Okay, so 2.5. Okay, so that's my y-intercept. Okay, and right off the bat, you can immediately see that you can kind of already see what the graph is going to look like, right? So it's going to go through -5. Okay, and on the top part, it's going to cross, it's going to look like this. It's going to cross this guy. It's not going to, this is still an open circle, but it's going to continue on like that. Okay, as so. Okay. Now, one thing that I feel like I don't know if I mentioned this, but I said that the horizontal asymptote can be crossed. To kind of check that, you can set the horizontal asymptote equal to the function. And if you get a point, then it does cross it. And if it doesn't, then it doesn't. So one way that you can do it is that you know that the function itself equals x plus 5 over x plus 2. We're going to plug in y equals 1. Okay, x plus 5 over x plus 2. And then we're going to solve for x. So I move that over, so you get x plus 2 equals x plus 5. When you subtract the x over, notice that you kind of get a contradiction. 2 cannot equal 5, which means that it does not cross the horizontal asymptote. Okay? And I'm not sure if I did that in the other videos. I don't think I did, but you, in order to check if the horizontal asymptote is going to be crossed, just set whatever the horizontal asymptote is equal to the original function. Okay. All right. So let's do another problem with the hole. So let's say you had f of x is equal to x plus 1, x squared minus 1 divided by x plus 1. So this one's a little silly because you can immediately see that this is already factored, and you can clearly see that there's going to be a hole here at x plus 1. So you have your new function, which is going to be this x squared minus 1. Notice that we don't have a rational anymore, and we have this x plus 1. So hole at x plus 1 equals 0, so x equals -1. Okay, so at x equals -1, you're going to have a hole. So now what you're going to do is you're going to plug in that -1 in there to see where exactly the hole is. You're going to get a 1 minus 1, which gives me 0. So at -1 comma 0, you have your hole. Okay. Now remember, we have our new function now, which is going to be this guy. This is going to be my new and improved function. Okay. So f of x is equal to x squared minus 1. This is something that we already know how to solve. This is just a parabola. Okay. So this is not even a rational. It's just a parabola going down 1 unit at -1. And then you just have your parabolic shape. Okay. Now the only thing that we have to do is incorporate this hole. -1, 0. Okay. So here's -1, 0. There's going to be a hole right there. So your parabola looks like this. So this guy right here, oh no, wait a minute, that's wrong. This one should be -1. -1, 0. It's this way. So it's going to go through here. Okay. And that's what basically the graph is. So basically this is not really a rational. It's basically a parabola in disguise, but there is a hole there. So notice that now, because we have our new and improved function, we're not going to follow the rationals at all. There's going to be no horizontal or vertical asymptotes, because that's not what we did with parabolas. We're just going to go ahead and just graph the parabola as usual. And usually that happens. You might end up with an equation of a line. You might end up with an x cubed. It really just depends. And luckily, you know how to graph all of those already. Okay, so we'll end this video with the slant asymptote. That's the last one that we really haven't been doing a lot. So we'll do this problem. F of x equals x squared plus 2x over x minus 1. Okay, so notice here that the reason why there's a slant asymptote here is because the degree of the top is 1 more than the degree of the bottom, which is basically a 1. So when that happens, there's a slant asymptote that occurs. How do you do that? You find the slant asymptote by long division. Okay, so you can use long division or you can use synthetic division. Now, be careful when you do synthetic division. Remember that you want the denominator to be a linear factor. Okay, so let me show you how this is going to work. So let's use synthetic division. We do have a linear factor. This is a -1, which means it's going to be a +1. And then this is going to be a 1, a 2, and then a 0 for the constant, that for a place value. Bring down the 1. You're going to get 1 times 1 gives me 1. This is a 3. 3 times 1 gives me 3. And you're going to be left with a 3 as a remainder. Now, typically, the slant asymptote, so let's just write this out. Since there's a degree 2, we bring it down 1, so it's going to be a degree 1. So it's going to be x plus 3 plus 3 over x minus 1. This guy, we don't really care about. This guy, don't worry about it. This guy, whatever we get left over, the quotient is our slant asymptote. That guy is a slant asymptote. So y equals x plus 3 is our slant asymptote. Now the reason why we don't care about this remainder term is because as x gets really, really big, this guy is not going to do anything. It's going to be negligible. Okay, so we only care about the quotient. Only care about quotient. All right, so now let's proceed as usual. Obviously, if we look at the horizontal asymptotes, there is none because the degree of the denominator is less than the degree of the numerator, so there's none. There is a vertical asymptote. The denominator in this case is x minus 1. So that means x is equal to 1. Okay, that's my vertical asymptote. My x-intercepts, we're going to set the y value equal to 0. So it's going to be 0 is equal to x squared plus 2x over x minus 1. Denominator goes away. So you're left with x squared plus 2x equals 0. You can factor out an x. So you have x plus 2 equals 0. X equals 0. And x minus is equal to -2. So here is where it's going to cross the x-axis at 0, 0, and at -2, 0. And then we're going to find my y-intercepts. And my y-intercepts is going to be when x is equal to 0. You're going to get y is equal to 0 squared plus 2 times 0 divided by 0 minus 1. You can see that this is just going to give me 0. So 0, 0 is going to be my y-intercepts. Okay, so let's start off by graphing the slant and the vertical. So the vertical asymptote is at x equals 1. So here's 1. Here's my vertical asymptote. My slant asymptote is going to be y equals x plus 3. So how do we graph y equals x plus 3? Well, remember that we're going to start at the y-intercept, so that's going to be 3. Okay, let me graph this a little bit better. So I'm going to go 1, 2, 3. So that's my y-intercept. And then the slope is 1, so you're going to go up 1 unit over 1 unit. So here is going to be my slant asymptote. Okay. Oh, I want to make this a little bit better. Let me just go like this. Okay. All right, so now what we want to do is we want to plot the points, okay? So we have 0, 0, so this guy's going to go through 0, 0. It's also going to go through -2, 0. So -2 is around here. Okay, so you can kind of see how this bottom part is going to be. So this bottom part, I'm going to try my best to draw it. So it has to go up through here, and then it has to go back down through here. So usually they don't have to be right at the edge. Okay, so then the next thing that you want to be able to do is plot a point. So you can plot in 2 to see where exactly this is going to be. So it's going to be, you have to use a little bit of perspective. So when I plug in 2, where was my function? Oh, it's right here. X squared plus 2x divided by x minus 1. We're going to plug in 2. 2 squared plus 2 times 2 divided by 2 minus 1. So here you're going to get a 4 plus another 4 divided by a 1 is going to give me an 8. So 8 is clearly way up there, which means that the other graph is going to look kind of like this. And I don't know if you can really see it, but kind of I'm way off the screen. So it's kind of looks like that. So so yeah, not the most prettiest graph, but basically if I were to draw it one more time, if I can, the graph kind of looks like this. Goes through there, and then up here you have this other graph. Okay, so this is what we call a slant asymptote. So so yeah, that's how you do them. They're not that too terrible because but you are combining everything that you've kind of learned about functions, about long division, about graphing, parabolas. Everything is being combined here.